Okay, I recently watched a YouTube video. It was an interesting video, by the way, and do recommend you watch it. And yeah, so I'm going to say it's an optional question, but like I say with any optional question, you get better options in life by taking those options. All right. Now the YouTube video was about this integral over here, and the guy did some interesting things. There's no doubt about it. And he arrived at the end of it. Oh, maybe it's a 20-minute long video. He arrived at the end. It wasn't. It's not an easy integral, by the way. He arrived to this answer over here. He did a lot of work. He did some interesting things, by the way. I recommend you watch it. So then I decided to myself, what would happen if I let Sage do it? And Sage certainly evaluated to that number. Sage was also able to do the antiderivative. Whoops, sorry about that. Was able to do this over here. And then I thought to myself, if I just did the limit for this one over here, I'll put out what I mean by that. The limit as r goes to infinity. And the limit of integration over there would be from 0 to r. And if you did that limit, you would still get the same thing, root 2 pi over 4. And again, the way the guy did the integration was quite interesting, but complicated, but interesting. It was very entertaining, by the way. So I decided I was going to give it a shot myself, right? Differently, though. I didn't want to just do what he did. I want to do something different. And that's what I think nice about integration. You can always take a different path. So the first thing I did was I looked at the denominator of the integram, which is 1 plus x4, and I said I was going to factor that. So what I did was I wanted to make the perfect square, and so I added 2x squared and I subtracted 2x squared from it. And then by doing that, I noticed that this thing over here is a perfect square. All right, what's that perfect square going to be? Whoops, it's going to be the x squared plus 1 quantity squared minus 2x squared. And that's the difference in perfect squares now. And then I factor that. Very simple. Then I did partial fractions. Right, so I'm doing partial fractions. They're irreducible quadratics, so I kind of do the form I like. And then I clear the fraction. What do you get? You would get 1. Whoops. You would get 1 equals, let's see, ax plus b. I'm not going to go through all the work, by the way, but x squared plus root 2x plus 1. Then you would get cx plus d. Let's see, times x squared minus root 2 times x plus 1. And then you pick easy numbers. Like you could pick x to be 0. You could pick x to be 1. You could pick x to be minus 1. Easy numbers, right? You could pick x to be whatever. I'm going to put down 2 now. And then you can get 4 equations and 4 unknowns, and you'll come up with the a, the b, the c, and the d. And if you do that, for the a, what you're going to get is root 2, if you go through that work. For the b, you're going to get 2. For the c, you're going to get minus root 2. And for the d, you're going to get plus 2. All right? Relatively simple. Make sure I'm saying that right, by the way. Actually, you know what? They're over 4. Sorry about that. I'm just looking at my work over there. It was arduous, though, to be honest with you. It was a lot of work getting through that. And, the bottom line is I just split it. I split it into two terms. And the way I did that was I factored out root 2 over 4. Whoops. From those terms. And I noticed something about this. I want to tell you what I'm noticing about it. I'm seeing this x plus root 2 here. So what I did was I divided top and bottom by x plus root 2. And what would you get there? Well, on top you get the 1. Here you get x if I divide this. And this would just be 1 divided by x plus root 2. And notice the same thing over here. And I did that. And you get x. Here you get plus, this is the 1 over x minus root 2. All right? So again, it might look worse to you, but actually I split it into 2 terms now at least. And maybe those terms did certainly look a lot alike. And I said to myself, well, let me just put the integration down now. So what do you get? This integration here is going to be root 2 over 4. I factored it out. I split into 2 different integrations now. All right, 2 different. All right. This is an indefinite. I'm going to put the limits down. That was part of my mistake in this. I didn't put the limits down, but I'll go through that later. I made a u substitution. And that u substitution I made was this over here. All right. So, basically fairly simple, but I want to point out it's kind of complicated what I'm writing down. I'm saying u is equal to, it's either x plus root 2 I'll call it the first one, or the second one could be x minus root 2. But the du in both cases is just simply dx. So I make the substitution. That's all I do. Make the substitution. Let me go through that with you. So, dx is du. Whoops. That's pretty simple. 1's 1. That doesn't change. This multiple doesn't change. What's the x going to be? Well, in this case, it's going to be, let's see, what was it going to be? Let's take a look at that. I'll write that down for you. It's going to be u1 minus root 2 would be equal to x. Well, I see that. And then what do you get? You get 1 over that. And the other one's going to be, it's not that bad, u2, it would be plus root 2, it would equal x. And I think I did that right over here. Not too bad. And then 1 over u. Remember, those u's are different. That makes it really complicated for me. And that was one of my errors, by the way. All right? I really should have used subscript like u1, u2. But anyway, it's still going to go forward. We'll still get it. All right? We'll go back over what I think you should be doing instead, by the way. The next thing I do is, I'm going to start to erase things now, is I start to think, that it's a complex fraction. I want to get rid of the complexity of it. So I multiply top and bottom by u over u. Let me go through that. So, 1 times u is u times u is u squared. That would be minus 2u, and this would just give you 1. The same thing over here. Multiply top and bottom by u, you get u squared, 2 root u, blah, blah, blah. Pretty simple. All right, let's keep going. The next thing I do is I complete the square. I'm not going to do it on both. I'll do it on one. And if you want to complete the square, it's fairly simple to do, by the way. You get u squared minus 2u plus 1, u squared minus root 2u. I take half of that, which would be, minus root 2 over 2. I'll write that down for you. Minus root 2 over 2, and square it. And what would you get? You would get 2 quarters, which is 1/2. Right? So I would, plus 1/2, and then plus 1/2, because I want to make the 1. And this now is a perfect square. All right? What's that perfect square going to be? It's pretty simple. It's right over here. And then plus 1/2. I do the same thing in the other one, complete the square. It's really kind of simple. I get this over here. And I'm getting things that, for the most part, shaping up pretty good. All right, let me keep moving. And next thing I do is, again, that fraction's bothering me. So I want to write it down for you. All right, so I'm seeing the u, whoops. I'm seeing the u minus 1 over root 2 squared plus 1/2. I try to factor a half out, right? What would that be? 2 u minus 1 over root 2 squared plus 1. Well, it's not so bad. And then I'm going to, try to simplify it a little bit. And when you get over there, you get 1/2. Well, that would be now, I'm going to pull this on the inside. So this is like, the square root of, not the square root. Sorry about that. I got to just do that again. Let me erase this again. That was a 2. I'm going to say it's the square of the square root of 2. All right, you pull that in, what do you get? Well, let's see. You would get root 2u minus 1 plus 1. All right? And then I pull this half out. It's over here. So it's going to be root 2, 4 times 1/2, which would give me root 2 over 2. I'm seeing that, and I'm seeing this over here. And by the way, I did the same thing over here. Same exact thing, not different. All right? And again, I'm kind of looking at that. I'm going to do the next stage, make another u substitution, but this time it's going to be v. I'll let v equal this. And again, this is a problem. I'll tell you what the problem is. In the first case, the v, I'll call it v1, is actually root 2u minus 1. In the second case, v2 is actually root 2u plus 1. All right? And remember, these u's are changing too. Like first one was u1, u2, blah, blah, blah. We'll go back over that. And again, these things created a problem for me. All right? So when I did that, it's really not that bad to do, is it? So what do you get? You get on the bottom, this would just be v squared plus 1. And let's see what the du would be. I'm sorry, the du, right? I want to do the du. So the du, let's see, dv root 2 du. So the dv, right? Let me write that down for you. So the dv over root 2 would be du. So I pull that on the outside, all right? Not that bad to do. We'll do that in a second, by the way. But I'm going to write this down, root 2 over 2, and then I pull that root 2 out, right? Because the du is dv over root 2, so I put 1 over root 2 over here. All right? And then I got to do this business over here. And what's that going to be? Well, v1 plus 1 equals root 2 over u. All right? So what do you get there? You get u would be equal to, whoops, I didn't mean to do that. The u, oops, I got an eraser there, u would be equal to v1 plus 1 over root 2. Well, I guess I could pull that out too, right? When you get over there, you get, let's see, another root 2, right? If I pull that out. And what's that going to give me? Oh, 4 in the bottom now. So I see that. All right. And then I get, the v plus 1. So things are working out pretty good. Now, a second substitution. Same thing over here, by the way. It's not much different. Not much different. You can do that one. You can do the other one. And then this is my real big mistake. All right. So I'm gonna say this is the real big mistake over here. I look at this, and I write this down up here. I tell you what the big mistake is. I'm not thinking about this. I'm thinking that these are the same limits. Now, the upper limits are the same. It's the lower limits that are different. So what I want to do is that, I always caution people about this, is be careful about those limits. Let me erase this business over here. I'm going to start to erase everything now and go backwards. But this is my big mistake over here. Not keeping track of those limits. All right? So what I want to do is go back right to the beginning, which I should have done. I guess it was just plain laziness. And I didn't do it. I didn't do it. We're going to do it now. Where the limit's going to be? 0 to infinity. Let's put the limits down over here. Infinity, 0. You know what? I can put these in red. 0, infinity. Let me get my eraser out and do this again. 0, infinity, 0, infinity. And let's take a look at it. So in this case over here, if x is infinity, well, regardless over here, the u is still going to be infinity. Just like over here, it's still going to be infinity. It doesn't matter like that plus or minus thing over there. But the lower limit does matter. All right? So, for example, if u, in the first case, and this is the first case, is going to be x plus root 2. All right? So let's take a look at that. Well, if it's 0, if x is 0, you get root 2. But on the other limit, it's going to be u. This is, 1. I'll put the second one down. This is the second one here. The u2 would be, what is that going to be? It's x minus root 2. So what's this over here? It's minus root 2 now. Because if x is 0, u would be minus root 2. So, I get, I'll just keep writing that down. Infinity, root 2, minus root 2, infinity, root 2, and then minus root 2. Infinity, root 2, minus root 2. All right? Let's go back over here now. All right? And let's write this down. Infinity, root 2, minus root 2. Now, granted, when I change these limits of integration, what's this guy going to be? It's going to be root 2 u minus 1. And this guy's is going to be, the substitute's going to be root 2 u plus 1. Well, I still got the infinities on top. That's not changing. What's the lower limit, though? Let's take a look at it. Well, it's going to be 2 minus 1 is 1. And what's this other guy going to be? Well, it's minus 2 plus 1, which is minus 1. So you realize this is where the big error occurred. What was I trying to do? Take these two integrations and pull them into one, and I can't do that. Why is that? Their limits of integration are different. One is at 1, one's at the minus 1, right? So this was a mistake over here. This is an error. All right? And again, I was confused. I had to go back and do it again. Look at why did I make a mistake? I didn't think about the limits. That's why I made a mistake. So what I do over here, I went through it. All I did was basically the same thing. Fairly at this point in the game, these are fairly simple integrations to do. One is the arctangent, the other one's going to be the natural log. Fairly easy to do. What I do, I write it down formally with the limits in it, and you should do that as well, by the way. And I evaluate the limit, and you get this over here. So things are all good in the end. They're all good. All right. So again, this is just a proper way of writing things down. At least I would like to believe that. And doing that limit, relatively simple, by the way. Thank you so much for paying attention.